So, okay. So, next is you are in the circuit shown in figure 17, the initial currents in inductor L1 and L2 have been established by the sources not shown. You assume that there are some sources, circuit I will show you later. So, there are some sources and initial your what you call currents in the inductors, two inductors are there in parallel and it has been established, right. So, the switch is open at t greater than 0 and determine IL1, IL2 and IL3 for t greater than 0. The ones for capacitor case RC circuit we took one problem where two capacitors were in series, but in this case a similar type of problem is taken when two inductors are in parallel. Here also only one case I will not tell you the reason. This is you to find out that you to try to think that why it has been taken, right. And finally, if you have any difficulty you have the forum, there we are giving your all answers, right. So, but this I will leave up to you, one or two things I will leave up to you. So, this is very interesting problem and just look at the circuit, right. All the direction of the current IL1, IL2 and this is another I3 is given, right, and your initial current through the inductor it is given 8 ampere and 4 ampere. This is also marked in that circuit, this is 8 ampere and this is 4 ampere and this inductor is 5 Henry, this is 20 Henry, and in problem it is said that in the circuit shown in this the initial currents L1 and L2 have been established by the sources, right, not shown, no need actually, we assume that it was established. The switch is open at t greater than 0, right, and you have to determine IL1, IL2 and IL3 for t greater than 0, that is IL1t, IL2t and I3t for t greater than 0 when switch is open at t greater than 0. That means at this time switch was open, right. Now look at this. So, if you look into that, this 5 Henry and 20 Henry are in parallel. So, it is like a resistor, you have to find out equivalent, the way we have found out equivalent resistance, here also you have to find out equivalent inductance. So, 5 ohm Henry and 20 Henry inductors are in parallel, therefore, L equivalent is equal to 4 Henry, right. So, this is very simple. Now, initial current that 8 ampere and your 4 ampere is given for inductor 1 and inductor 2, that is IL1 0 and IL2 0. So, here it is IL1 0 is equal to 8 ampere and IL2 0 is equal to 4 ampere. Therefore, ILEQ equivalent inductor current will be IL1 0 plus IL2 that is 12 ampere, right. So, this is actually that is ILEQ is equal to IL1 0 plus IL2 0, that is 8 plus 4 is equal to 12 ampere, both we are adding. So, an equivalent your what you call inductance is 4 Henry, the parallel equivalent is 4 Henry and this is the voltage Vt we have taken, some point we have taken Vt and this is the current I3. If you look into that, this is open, as soon as you this is actually open, as soon as you open it, these two parallel equivalent we have taken and this is the current I3. So, and this is 8 ohm resistance. So, this is the equivalent circuit, right. Now, in this case tau is equal to LEQ upon R. So, your LEQ is equal to 4 Henry and R is equal to 8 ohm. So, 4 by 8, so 0.5 second. So, tau is equal to 0.5 second. Therefore, you know now that generally we know now IT is equal to I0 to the power minus t upon tau. So, here also I3t is equal to initial current to initial this current that ILEQ 0 is equal to 12 ampere, right. And your tau is equal to we got that is your somewhere I have mentioned that 0.5 second. So, basically we know this one this is for I3, but in general we got no IT is equal to your I0, say capital I0 or small I0 this thing your e to the power minus t upon tau, right. So, in this case your what you call the tau is equal to your 0.5 second, that is why it is coming 2t and this I0 is equal to that combined inductors that this thing your initial current is equal to 12 ampere, that also we have made it 8 plus 4 is equal to 12. So, that is why it is 12 e to the power minus 2t ampere, right, it is given t greater than 0 plus, right. So, therefore, voltage across the 8 ohm let me clear it, therefore, voltage across the 8 ohm resistance is Vt is equal to I3t, because this I3 current is flowing to 8 ohm resistance that is given in the circuit. So, 8 into I3t if you multiply it will be substitute I3t here, substitute I3t here, if you multiply it will be 96 e to the power minus 2t volt. So, at t is equal to 0, you put here at t is equal to 0, that means V 0 will be 96 volt, right. So, that means this one, if you go to this circuit, the initial voltage, I mean at t is equal to 0, this voltage will be 90 or 96 volt, right. So, next one is that next is that when we are writing that we know that your what you call that IL1T, right, that is your Vt is equal to, in general, Vt is equal to L into di upon dt. Same for inductor 1 and inductor 2, that parallel inductors 2 are there, right. So, when you make it, I mean we know that in general V is equal to L into di by dt, that we know, right. That means di is equal to your what you call your di is equal to 1 upon L, right, then V into dt. If you integrate this like this, so 1 upon L, in general it is V dt. So, this is my voltage V and this for inductor 1 and this is L1, this is everything is okay, but after this minus IL10 is there because initial current was there 4 ampere. So, why we have taken here the minus sign, right. So, minus or plus, this is a question to you, right, same as capacitor I put this question. So, hope when you will go through this video lecture, right. So, this one or two things I am leaving up to you just to see whether you can answer correctly or not. You just put the answer in the forum, at that time we will see it, otherwise we will answer immediately, don't worry, don't worry, but just leaving up to you, just have some thinking. Everything we are trying to tell, everything from my side I am trying my best to tell everything, but this is one or two I am leaving it to you, that just think, right. Similarly, your what you call, and if you integrate and if you put this value, this 8 ampere, right, IL10 8 ampere. So, it is coming actually your 1.6 minus 9.6 e to the power minus 2 t ampere, this is for t greater than equal to 0, right. Next, similarly, this same question was there for when two capacitors are in series, right. Similarly, IL2 also, it is here it was 5 Henry, L1 was 5 Henry, here it is 20 Henry and it is 0 to t 96 e to the power minus 2 t dt. So, minus IL2 0, right. So, here also minus sign is there. So, this is a question to you that why it is. So, if you put all if you do the integration and simplify, right, and you put IL2 0 initial condition, that IL2 0 I think it was 4 ampere, you put it here 4 ampere and you will get IL2 t is equal to this simplification minus in bracket 1.6 plus 2.4 e to the power minus 2 t bracket close ampere, this is for IL2. Problem is very simple, but only thing that IL1 and IL2, why minus sign, right, this is a question to you. So, after this this is a typical problem, everything is okay, and this voltage Vt means this whenever we are taking that your what you call at t is equal to 0. So, this voltage Vt, that means this is the voltage we have taken when this switch is open, right. So, this is my Vt and this same voltage is impressed across this one and across this one, that is why that IL12 and IL22 we have obtained and initial current is given, right. So, only thing is that minus why minus IL10 and why minus IL20 in those two expressions have been taken, this is a question for you, right. So, next one is that another example. In this case, the switch in the circuit, example 7, the switch in the circuit I will show you, has been closed for a long time, right, and at t is equal to 0, the switch is open, determine IT for t greater than 0. You have to find out t. The switch was closed, it has been closed for a long time. If this switch is closed for a long time, that means this switch was closed, right. This switch was closed, and in that case what will happen, if the switch is closed for a long time, then this inductor will behave as a to DC, because it is a DC source, it will behave as a short circuit. In that case what will happen, this resistance has no current will flow through this resistance, it will be completely isolated, because that just I am telling the current flow will take like this, because this switch was closed for a long time. So, for DC When switch is closed for a long time, inductor will act as short circuit, whereas capacitor acts as open circuit. These things you have to keep it in your mind. So, if it is so, just see how is the circuit. I think here I might have made it for you. So, this if it is so, this is the equivalent circuit. I told you this thing will not be there, this 7 ohm will not be there, because this inductor is short circuited. So, no current will flow. So, circuit will be like this. So, this 7 ohm should not be there. So, that is why it is 4 volt and some current I1 is flowing here, right. I1 is flowing and this 5 ohm and 2 ohm are in parallel, and this current is IT, right. Now, if you just if you look into this, then that for obtaining the current I1, it is simple DC circuit. It is simple for obtaining the current I1. This 5 ohm and 2 ohm, they are in parallel, right. With that this 3 ohm is in series. So, R equivalent will be 3 plus your 5 into 2 by 5 plus 2, that is your 3 plus 10 by 7 ohm, right. This is R equivalent, and therefore I1, this I1 will be your, I mean, if you take this equivalent one, then I am not drawing the second circuit, is understandable to you. Therefore, it will be 4 divided by 3 plus 10 by 7 ampere, because this source is 4 volt, right. So, let me clear it. So, if this is your what you know that I1 is equal to 4 by 3 plus 10 by 7, 28 upon 31 ampere. Now, the current division I2 will be 5 by 5 plus 2 into I1, right. Now, this I1 you know, so your IT will be, in terms of T, say here also if you want, it is a function of T, say. So, it will be the current division, what is the current flowing through this 2 ohm resistance, that is your IT is equal to 5 by current division 5 by 5 plus 2 into your I1 T, right. This is the current division. So, 5 by 7 into I1 T. So, let me clear it. Right. So, in this case, this is 5 by 5 plus 2 into I1. So, that is your IT, your what you call IT will be your, this is actually just 1 minute, one correction I will make it. So, better you do not put it I, simply write your I, simply write it I, right. So, 20 upon 3 ampere for T less than 0, right. It is initial condition. So, by mistake I have made it I T. So, T better not write, simply you put I, right. So, let me clear it. So, since the current through an inductor cannot change instantaneously, that means I0 is equal to I0 minus is equal to 20 upon 31 ampere. This is the initial thing, right. For t greater than 0, the switch is open, right, and the voltage source is disconnected, and it is shown in figure this thing. At t greater than 0, the switch is open. So, come to the circuit first, right, this circuit first. At t greater than 0, the switch is open. The switch is open means this part is not there, this part is not there, right. So, if this part is not there, let us see how the circuit is, right. So, in this case that your this IT is there, 3 Henry inductor is there, and this 2 ohm and 5 ohm are will be in series, right. So, that means this 2 plus 5, this is your 7 ohm, and this 7 ohm are in parallel. So, equivalent will be 7 into 7, right, by your 7 plus 7, that is actually 7 by 2 ohm, right, actually 7 by 2 ohm. So, this equivalent is 7 by 2 ohm, then your tau will be L upon R, whatever time constant will come, your L is 3 Henry. So, in this case your R eq is equal to 49 by 4, that is 7 by 2 ohm, right. I did not written further, but it is 7 by 2 ohm. So, time constant is L upon R eq. So, 3 upon 49 by 14. So, 6 by 7 second. So, thus IT is equal to I0 e to the power minus t by tau, this we know. So, that is 20 upon 31, and tau you got 6 by 7 second, you substitute, you will get 20 upon 31 e to the power minus 70 upon 6 ampere. So, IT is equal to, that means IT is equal to 0.645 e to the power minus 70 by 6 ampere, that is for t greater than 0. So, this is a simple problem, only you have to little bit your what you call some basic to the DC. If the switch is closed for long time, that inductor will behave as a short circuit, and for the capacitor it will behave as a, for DC, that open circuit. This thing you have to keep it in your mind, right. So, this is, I hope you have understood this simple problem. So, next one is, in the circuit shown in figure 22, you have to determine Ix, Vx and I, that is your, you have to determine your Ix, this is your Ix, then your Vx, that is the voltage across this 3 ohm resistance, and I, that means this is the I for all time, right, that is which I is current flowing to one Henry inductor. Assume that the switch was open for a long time. Here in this case it is given opposite, that switch was open for a long time, right. So, if switch was open for a long time, first you have to see that initial condition, right. So, let me clear it. So, when the switch was open for a long time, so this will be the circuit, because if switch is open for a long time, if the switch is open for a long time, that means that it is a DC volt 110 volt, right, and inductor behaves as a short circuit, inductor behaves as a short circuit. So, it is short. So, in that case what will happen, that if it is open for a long time, the current will flow like this, and there will be no current in the 6 ohm resistance, because it behaves like a short circuit. So, there will be no current here. So, it will take this path, it will go like this. So, no current will flowing. So, initial current to Ix 0 is 0, right, and initial to the inductor initial current is, it is 2 ohm and 3 ohm will be, this is open, right, it was open for a long time, and only at t greater than 0 it was closed. So, it was open for a long time. So, initial current, that I 0 will be 100 divided by 2 plus 3, that is 20 ampere, that is the initial current that is flowing to the inductor, right, and Ix 0 at it will be 0. So, so let me clear it, and if you try to find out the initial voltage Vx 0, that will be your 3 into 20. So, it will be 60 volt, right. I mean, if you want to find out what is the initial voltage Vx 0, it will be 3 into 20, that is your 60 volt, right. So, this is the circuit I have drawn. So, 6 ohm is totally isolated, right, it is not, no current is flowing here when switch was open for long time, and this is 2 ohm 3 ohm are in series. I made it for you. So, Ix 0 is equal to 0, I told you, Ix is equal to 0 initial, and It, it is actually your what you call, this is actually switch was closed for this thing. So, I suggest better, instead of writing T, you just write I initial condition, the way I wrote It 0 with, do not write T. This is while making it I made some your what you call the writing error. So, it just make I 0 is equal to 20 ampere and make this was V 0, right, that is your 60 volt. This is because this is for t less than 0. Of course, one thing is there, as I have mentioned, t less than 0 or t less than 0. So, It here also you can make it for all t less than 0, it is also It also is valid, but you just make it for I 0 and Vx 0, both are valid, but still I have made it, because as you have mentioned it here. If you have mentioned, I overlook this one, if you have mentioned this one, then It and Vx is okay. If it is not mentioned, then you put initial value, that I 0 and V 0, right. So, and that is why I 0 is equal to a right 20 ampere, that is the initial current, right. So, let me clear it. So, now for t greater than 0, the switch is closed, right, switch is closed, so that the voltage source is short circuited. I mean, as soon as your, if you look into the circuit, when if you look into the circuit at t is equal to 0, this switch is closed, that means this voltage source is short circuited, because this is short, right. So, what will be the equivalent, or what you call equivalent circuit in that case. So, in that case what will happen, that this is your equivalent circuit, the voltage source is short circuited. So, this 3 ohm and 6 ohm resistor are in parallel, right, and their equivalent will be 6 into 3 by 6 plus 3. So, 2 ohm, right. So, and this is 1 Henry inductor. So, that means we are writing parallel resistance, but at the same time at the inductor terminal, if you make it like this, R Thevenin, that is nothing but the two resistors are in parallel, 3 into 6 by 3 plus 6 is equal to 2 ohm, right, and tau is equal to, we are writing L upon R Thevenin, that is L is 1 Henry, here L is given 1 Henry, and your this one given that your R Thevenin is 2, so half second, tau is equal to half second. Now we know that IT is equal to I0, this source free circuit, you know I2 is equal to I0 to the power minus t upon tau. So I0 is equal to 20 and tau, your tau is equal to half, so e to the power minus 2t ampere for t greater than 0, right. Applying KVL, we have Vxt plus Vlt is equal to 0, right. Now if you apply KVL in this circuit, if you apply KVL here, so if you move this, that is V plus Vx plus Vl is equal to 0, right. So apply KVL in the circuit, then let me clear it. Right. So Vxt is equal to minus Vlt is equal to minus L di upon dt. So it is L is 1 Henry minus 1 and di upon dt is, you take the derivative of this one. So 20 into minus 2 into e to the power minus 2t. So Vxt will be 40 e to the power minus 2t volt, that is for t greater than 0, right. So and Ixt is equal to Vlt upon 6, because this whatever voltage you got Vlt, right, this 6 ohm and this 6 ohm and 1 Henry are in parallel. So whatever you get across this is Vl, right, then Ix will be your, in general, Vl, not writing t, later we will see that, understand this divided by 6 ohm resistance is the current, right. So in this case we are writing Ixt is equal to Vlt upon 6. So V, your what you call Vlt is given, that your we have got Vlt is equal to your minus Vlt is equal to minus L di this much, right. So Vxt is equal to this much and Vlt we are writing minus, why, because here it is Vxt is equal to minus Vlt and Vxt we got this much, that means our Vlt is equal to your minus Vxt. So that is actually minus 40 e to the power minus 2t, that is why this minus sign is here, right. So minus 40 e to the power minus 2t upon 6. So Ixt is equal to then minus 20 upon 3 to the power minus 2t ampere. This is, it is said for all time, that means if you mention this Ixt is equal to 0 ampere for all t less than 0 and Ixt is equal to minus 20 upon 3 to the power minus 2t ampere for t greater than 0. This way you should write. When you say all t means, it is actually in general it is actually minus infinity to plus infinity, right. So that is why for 0 ampere it is like this, t less than 0, and it is Ixt minus 20 upon 3, this we got. Similarly for voltage we got that 60 volt, that t less than equal to 0, right, that is, and 40 e to the power minus 2t. When you mention this one, at that time Vxt is equal to 60 volt, right. If you don't try to mention, then we will assume that it is initial value 0, but for anything less than t less than 0 it is 60 volt, right. Similarly It also initially 20 ampere we got, that is for all t less than 0, and because switch was closed for I think in this case it was open for a long time, and 20 to the power minus 2t ampere for t greater than 0. If it says all time, then with this way you will write the answer, right, this way you write the answer. In general it is minus infinity to plus infinity, whatever breakup is there for time you write, right. So next is, I hope up to, so the you know this is up to, this is source free circuit whatever we have studied so far, right. So the next is that singularity functions, because we have to take now your what you call that where source is there in the circuit. So before that little bit we will learn about singularity function. So singularity function are function that either are discontinuous or have discontinuous derivatives, right. So a basic understanding of the singularity function will help us to make sense of the response, especially the step response of RC or RL circuit, right. So singularity function are also called the switching function, right. So, sometimes it is called, all I have underlined the switching function, and very useful for circuit analysis, right. So, in circuit analysis, the three most widely used singularity function are the unit step function, the unit impulse, and the unit ramp. These three functions, one is unit step, the unit impulse, and the unit ramp, all are underlined, right. So, basic understanding of these three functions helps to make sense of the first order circuit, right. So, following your what we call sudden application of an independent DC voltage or current source. First, we will understand this one by one, then we will go to that your what you call that your at that time source will be there in the circuit, at that time we will see the transient response, and you will find things are very easy, right. So, unit step function first, right. Basically, unit step function, this kind of singularity function, step function, ramp function, all sort of things you will find mostly used in the circuit as well as in the control system, right. So, for unit step function, that ut is 0 for t your what you call for t less than 0, right, and 1 for t greater than 0. So, ut is equal to 0 for t less than 0 and ut is equal to 1 for t greater than 0, right. So, this way you define the unit function, your what you call unit step function. So, it is, but one thing is there, it is undefined at t is equal to 0, but when it is undefined at t is equal to 0, it is less than 0, t less than 0 it is 0, t greater than 0 it is 1, but it is undefined at t is equal to 0, right, where it changes suddenly from 0 to 1. And second thing is, it is dimensionless quantity, this thing we have to keep it in our mind, it is dimensionless quantity. So, figure 25 shows the unit step function, I will show you the figure. So, this is the unit function depth time, your depth of all time, how you define unit time function. So, this is your unit time function, but remember at t is equal to 0 it is undefined, right. So, in for this case ut is defined, this is unity, and this is like this we have drawn, because for t less than 0 it is your 0. So, but at t is equal to 0 your what you call it is undefined. So, instead of t is equal to 0, if the sudden change occurs at t is equal to t 0, that is t 0 greater than 0, right. So, what will happen? Suppose instead of t is equal to t 0, if the sudden changes occur at t is equal to t 0, where t 0 greater than 0, the unit step function can be expressed as that we can write, if t 0 greater than 0 at a t is equal to t 0, then u t minus t 0 is equal to 0 for t less than t 0, and it is 1 for t greater than t 0, and at t is equal to t 0 it is undefined, right. So, 29 indicates that your ut is delayed by t 0 second and is shown in figure. So, it is delayed, right. So, it is delayed, it is made it has been made like this, this thing is your less than t 0 and this is your greater than t 0, and right, and this is your 1. So, this is u t minus t 0, that is delayed by t 0. Now, if it is advanced by t 0, how it will look like? So, next is if the sudden change at t is equal to minus t 0, the unit step function becomes, in that case it is u t plus t 0 is equal to 0 for t less than minus t 0 and is equal to 1 for t greater than minus t 0. So, this is equation 30 say. So, this equation 30 it indicates that ut is advanced by t 0 second and is shown in figure 27. So, it is advanced. So, this is minus t 0, right, and this is 1, and this is the thick line, again I am not marking by blue color, this is a thick line for less than minus t 0, this less than minus t 0 is 0. So, this is thick line and this is your greater than t 0, right, and it is u t plus t 0 time, right. So, unit is your unit step function advanced by t 0. So, these three, that ut, that means ut, this is ut, hope you have understood this ut, this is your ut minus t 0, this is the plot, and this is your ut plus t 0, right, if it is advanced by t 0. So, this is the plot how will show the unit step function, right. So, step function can be used to represent an output abrupt change in current or voltage, and this kind of abrupt changes occur in the circuit of digital computers and control systems, right. For example, For example, let us consider the voltage. Let us consider the voltage V t is equal to, it is given 0 for t less than t 0 and V t is equal to V 0 for t greater than t 0. This is equation 31. Suppose this voltage we are writing like this, if it is 0 t less than t 0 and V 0 t greater than t 0, we are writing like this. It can be expressed in terms of the unit step function as V t is equal to V 0 u t minus t 0. We saw now this step function, your this thing u t minus t 0 is equal to, for t less than t 0 it is 0 and for t greater than t 0 it is 1 and multiplied by u t, this is u t minus t 0. So, this voltage right, if it is given like this, we write u t minus t 0. We know for t less than t 0 it will be 0. So, V t will be 0 and for t greater than t 0 your u t minus t 0 will be 1. So, in that case V t will be V 0, right. This we have seen from that, right. When t less than t 0, your u t minus t 0 is equal to 0. So, in that case V t will be 0, right. Now, let me clear it. So, similarly, when your t greater than t 0, u t minus t 0 is equal to 1, that means this one will be V 0, right. So, this expression, this whole thing, equation 31 can be written in this form, right. So, it is understandable, right. This equation can be represented by equation 32, right. So, let me clear it. And at if t is equal to 0, if t 0 is equal to 0, then this 32 can be written as V t is equal to V 0 into u t, right. So, with this just show you the circuit, right. So, figure 28a shows a voltage source V 0 u t and its equivalent circuit is shown. So, this is V 0 u t, the voltage source is given, right. For t less than 0 it is your what you call u t 0 and for t greater than 0 it will be V 0. So, this when the switch position is like this, so 1 and 2, this is actually your what you call that it is 0, right, because 1 and 2 is short circuit. If it is 1 and 2 make like this. So, if the switch position if the switch position is like this, then it is short circuit, right. So, in that case I can say that t less than 0 for example, right. So, in that case this your what you call, there will be no output voltage, that V 1 2 is 0, that V 1 2 is equal to V 1 2 is equal to V t is equal to 0, right. But when switch position has gone from this to this, I mean when it is there, when it is connected, forget about this, when it is connected, at that time your V 1 2 is equal to V t is equal to V 0, right. So, this if we draw V 0 u t, this circuit, then your what you call, let me clear it, this is the equivalent circuit from here. If you make V 0 and this is your how you will make it in a switching logic, right, how you will make it a switching logic. So, just 1 second, right. So, this way you can make it. So, voltage source V 0 u t and its equivalent circuit, and whatever I said is explanation is given. When your what you call, it is clear that terminal 1 or 2 are short circuited, that is V t is equal to 0 for t less than 0 and for t greater than 0 I told you V t is equal to V 0 appears at the terminal 1 and 2, that is V 1 2 is equal to V 0, right. So, today today up to this, I mean for this up to this, thank you very much, we will be back again.